working on a Raymond order picker. This is a 520 OPC, and the code that we're having right now, I'll show you when I turn it on. Okay, let's plug in the battery first. Key on. Self-test, everything looks good. It's until you step on the deadman. Code out, you can see code GD. Okay, pulled out the service manual for this truck, and you can see that's code G4, and we have code GD. So G4 is an open detected in the steer control circuit. Definition is no neutral pulses detected when the truck is not moving and operator is on the deadman pedal. So as you've seen earlier, the code only comes up when we actually step on the deadman pedal. Code GD is a no steer motor encoder pulses, but the way I look at this is I would go with the steer encoder first, because the neutral pulses is already coming from the controller for the steer motor. So the neutral pulses is being sent by the steer motor controller to the VFC. So if there were no steer motor encoder pulses coming from the motor to the steer controller, then obviously there would be no neutral pulses. So I would concentrate on looking at the encoder bearing signals first, and then see where it takes us. Okay, so this is the steer motor for this guy. Alright, so G4 and GD concerns the encoder bearing, and you can see that is the wire that comes from your steer motor. 4 wires, power, ground or negative, and then 2 signal wires. Signal wires are going to be the blue and the white. So right now I have my channel A and channel B for the scope, and I'm back probing the signal wires right now. Focus on the screen, so you have my channel A, channel B, 10 volts on channel A and 10 volts on channel B. And so 500 milliseconds per division. So I'm just going to focus you on the screen right now, and we're going to look at the signal when we key on. Let's step on the deadman. Okay, so I don't know if you heard that. Alright, but let's pause this right now. Okay, we pause this and let's look back on it. Okay, so right here we got 5 volts, 0 on the other one, and we go back a bit more. That's when we keyed on, and you see there was 5 volts going right here onto channel B. 9 something volts actually. Oh, okay, the wrong way. Right here, that would be 4.75. Alright, so 4.75, that should be normal enough for it. And problem is, when we start it up, it should give out a signal. But right here, as you can see on this part, let's try to zoom in on this guy right here. See that part right here? Seems like right now we have an encoder bearing problem on this one. Okay, so at this point we're pretty much, we know that there's a problem with the encoder, but there's a couple more possibilities on or testing that we have to do. So first is going to be the integrity of our signal wires leading to the computer or from the encoder itself, and the negative. So I'm still hooked up to one of the channels. So with the oscilloscope earlier, we saw that this channel was always at 5 volts and was never moving, so it kind of wants to move, but it couldn't reach 0 or negative, right? So this is how we're going to do this. We want to test if our signal wires, channel A and channel B, leading to the computer is good. So the other channel, which is the white, where I have the blue trace hooked up earlier, it was at dead zero. It was never moving, right? So this is 4.74. Let's check on the other side. So close to 0, 0.2 something, right? And this is how I test the integrity of my signal wire leading to my computer. So what I'm gonna do right now is I'm gonna unplug this sensor and watch the reading. Okay, so I unplugged it, and you can see the reading on my meter went up to 4.79 or close to 5 volts. So this is the pigtail leading to my encoder in the motor, and this leads to my computer. We saw it jump from 0 to almost 5 volts, and that would tell me that my signal wire from here up to the computer is good. There's nothing wrong with that. And let's see on this one, other side, did it change? No, same reading. So I know for sure that my signal wires are intact. So for this reading, I was hooking up my black lead on my meter into the negative, battery negative. Alright, so let us test now the negative part of this, the negative supply. I know there's already a positive supply on this, but you know what, let's just test it out. So okay, 12 volt supply is good. Okay, one last part to do. Integrity of my wires leading to the computer. So we know that we already have, right now I'm hooked up to the positive supply, and my black lead is attached to the negative of the battery, and you see 11.52 volts. Alright, so the only wire that's left to be tested is going to be the negative supply. So what I'm going to do is I'm going to take my connector out, the black lead from the battery negative, right, and I'm going to move it right here, back probe the negative supply, and as you can see, .51. So that would tell me that I have a good negative supply. So we tested the signal wires, we tested our positive, and we tested our negative. So the problem is not going to be within the wiring, this is going to be an encoder.
Okay, let's do a brief explanation on why we always see a 5 volt even though we took out the connector for the encoder bearing. So we were back probing right here towards the computer, which is the white and the blue. So what's happening was, inside the computer there would be, I'm not really exactly sure if they had the resistor inside, but it would have a 5 volt reference inside the computer, right, and it goes out here, and so the sensor, the steer motor encoder, is actually pulling that reference signal to the negative. So whenever the sensor itself is not producing the 5 volt pulse, it's just pulling the signal with the 5 volt reference signal to low, to 0, and that's what's happening to it. And so this is a quick and dirty test again to check if my wiring going to my computer is okay, or is it still intact, because otherwise you would not see that 5 volt reference signal here at the connector end.
Okay, finally replaced the encoder bearing on that steer motor right now, so there's no more codes. Steer it, Gus. Okay, steering. And this is how it should be looking like. So channel A and channel B. Alright.